All right. 9.2 angles in radian measures. 9.2 angles in standard position. In a coordinate plane, an angle can be formed by fixing one ray, the initial side, and rotating the other ray, the terminal side, about the vertex. So here's your vertex. Here's your vertex. The initial side right here. An angle is in standard position when its vertex is at the origin. There's the origin. Its initial side lies in the positive x-axis. So the initial side is positive x-axis right here. You can think of this as to the right. You can think of this as to the east. But this is a positive x, positive y, negative y. You can think of that as north, south, east, west. But the initial side, where you begin, where you start, it's always going to be pointed that way. Always for the initial. Now, in standard position, the end, the terminal side, where it terminates, where it ends, the terminal side, so it can always rotate right here. So the vertex is going to be right here, and that's going to rotate. So if it ends right here, that's your angle. This would be your initial side, that's your terminal side. If it rotates and it's right here, this would be quadrant 2. That means this is the entire angle. Okay, the initial side's right there, the terminal side is right here. This happens to be in quadrant 2. You can have something that's ends in quadrant 3. The angle would be right to there. That's quadrant 3. And it could be in quadrant 4 if this thing rotates all the way around to right here, the terminal side's right there. That means the angle would be going all the way around, and the terminal side would end right. Come on. There. Okay. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So how do we draw an angle in standard position? That's 110 degrees. Okay, let's do that. 110 degrees. So you just have to sketch this. You don't have to be perfect. So I know that in this right here, in a full circle is 360 degrees. Going straight up or north, that's 90. It's always going to be 90. To the left or to the west is 180 degrees. Straight south or straight down is, it's not 360. This is 360. I mean, it doesn't like, that's 270. 270 degrees. That's better. See, the dog didn't like that mistake. 110, is it between 0 and 360? No. 110, is it between 90 and 180? Yes, it's over here. It's in quadrant 2 somewhere. So halfway between 90 and 180 is 135. So 110 is going to be someplace over there. So you have, that's your initial side. This is your terminal side, and like 110 degrees. Done. I don't think the dog likes that. Bina. Negative 800. Ooh, I forgot to tell you about positive and negative. If it's traveling in this direction, that's considered a positive angle. This is counterclockwise, anti-clockwise. If the angle is traveling in this direction, it's considered a negative angle. That's clockwise, okay? So negative, I know it's the initial side is going to be right here, and it's going to go this way. Negative 800. Negative 800. 800. Whoops, negative 800. Negative 800. How many times does 360 go into that? Divided by 360 equals, it goes in negative 2.2222. So it's going to go two full times around the circle in the negative direction. Okay, now watch this. It's going starting in the negative direction. There's 1. There's 2. And it has to go another 0.22222 times. So 0.22222 has to go another 0.22222 times around the circle. I'm going to take that and multiply. How many degrees in a full circle? 360. So I'm going to multiply that by 360. you get 80 degrees. So I have to go another 80 degrees. So that's 90. That's 90. So that's 90. There you go. That's going to be 90 degrees right there. So it's going to be almost 90, somewhere on here. So it's going to be like that. So, and so what is there? 1, 2, and more. And that's negative 800 degrees. 1240. 1240. 1240. And take that. How many times does 360 go into that? 360. 3 full circles in a positive direction. 1, 2, 3 full circles plus another point. So right, 3.44. So I'm going to take 0.4444444 and multiply it by how many degrees of full circle? 360. And you get 160. So I have to go an additional 160 degrees. Remember, that's 90, that's 180, so it's going to be closer to 180. So it's going to be out over here somewhere. So that is the terminal side. It's going to be 1240 degrees, and this is your initial side right there. Boom, done. Okay. If two angles differ by a multiple of 360 degrees, then the angles are coterminal. Oh, so coterminal angles here. If I took this 110, what if I added another 360? So actually I should have said, find coterminal angles with number 5 and number 7a, so these two. Find a positive one, the smallest positive and the smallest negative. Okay, so there's nothing between 0 and 110, so I have to either add 360 or subtract 360. That's what we have to do. So if I add 360 to this, 360 plus that, I get 360, 70, so 110. If I add 360, you're going to get 470. So that means if I did this, if I went around once, and then go another 360, that'd be 470 degrees. Has the same terminal side, has the same terminal side. The same initial side and the same terminal side. They start at the same spot, they end at the same spot, just one just goes around a whole bunch more times. Okay, what about a negative? So this minus 360, 110 minus 360, you get negative 250. Negative 250 degrees, you need that degree symbol. So these are all coterminal angles. They all start at the same spot, they all end at the same spot. What about this one? 7, 8, negative 800. So if I take negative 800, negative 800, I'm going to add 360 to that. And so negative 800. Another coterminal angle with that would be negative 440. Add another 360, another negative 80 degrees would work. And if I add another 360, positive 280 degrees. Now, do I really need to put positive there? No, I need to have that degree symbol though. That degree symbol tells us that's degree mode, degree mode, degree mode, degree mode. It's in degrees. It's not in any other kind of units, it's degrees. You say, wait, what do you mean another unit? Well, we only have degrees. Right now it is, but until we flip the page, we're going to learn something else. Okay. Oh, how handy. Angles can also be measured in radians. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So here's a circle, and this is considered the radius from the center to any point in the circle. So if we took something, a piece of string, or in this case a cord, if I took something that's the same length of that radius and laid it across this arc, that means it would be right to there. The arc length right here, this arc length is the same length as the radius. This would be considered 1 radian. Okay, that's considered 1 radian. And you can keep on going if you wanted to take that distance. There's 1. That would be considered 2 radians, and so on and so on and so all the way around. Okay. The circumference of a circle is 2 pi r, 2 times pi times r. So there are 2 pi radians in a full circle. And 1 full circle is 360 degrees. And if the radius is just, we're just going to call it, the radius is 1. Whatever, I don't care what units you use, feet, miles, inches, centimeters, we're going to call that a radius of 1. So if that's 1, 2 times 1 is 2 pi. So, by the way, the radians unit, normally in geometry we use degrees. Radians is one that's introduced for when you get to calculus. Radians is much more useful in calculus than it is in, it's not useful at all in geometry, but when you get into more advanced mathematics, it's much more useful. It's just another language. It's just a different way to say the same thing. But it's more useful when you start using advanced calculus, advanced mathematics. Calculus is one of them. So in a full circle, there are 2 pi radians. And now we have to learn how to convert from degrees to radians and radians to degrees. So converting degrees to radians, you take your degrees and you multiply it by pi radians over 180. So convert this to radians. It's 135. You know that's degrees because there's a degree symbol right there. How do you do this? How do you convert it to radians? You multiply it by pi over 180. 180 is in degrees. This degree symbol and that degree symbol cancel. 5 goes into both of these. I think 45 goes into all. 135 divided by 45. 45 goes into that 3 times. 45 goes into that 4 times. And nothing else. So your answer is 3 pi over 4 radians. Now, what I don't like are many books, and I found this in high school and college. A lot of times they just say 3 pi over 4, and there's no units. What do you mean there's no units? They just write 3 pi over 4, and they don't put any units whatsoever. That always bugs me. It's in radians. Make it obvious that it's in radians. So I do this. A lot of times you see this, and the only indicator for me that it's in radians is there's a pi there. If it was in degrees, you would have to have that degree symbol. Okay. How do you convert that to radians? You just multiply it by pi over 180 times pi divided by 180 degrees. Those degree symbols cancel. 10 goes into this 4 times. 10 goes into this 18 times. 2 goes into that twice. 2 goes into that 9. So we get 2 pi divided by 9. You can leave it like that technically, and that's acceptable in high school and college. But to me, wouldn't it be so much simpler if they required you to just put that for radians? That would make it so much easier. But if you want, you can just put 2 pi over 9. Okay. Okay, next, how do you convert from radians into degrees? What? Oh, you just multiply by the reciprocal. You just take this and you flip it over. Flip it over. Okay. Convert 5 pi over 4 radians. In fact, you don't even have to have the word radians there. 5 pi over 4. The only reason I know that's in radians, there's no degree symbol there. Another hint is I've never seen degrees. I've never seen them use pi and a degree symbol. It is, I'm not saying it's not possible. I have never seen it. Okay. How do you, so we just have to multiply by the reciprocal. It's 180 degrees divided by pi. This is actually, be nice if they actually put radians right there, huh? Nice if they've actually put radians. Here they do, but yeah, no. This radian is on top. That's in the denominator. Top and bottom, they cancel. The only units remaining now is degrees. So that when I know the units are going to be in degrees, the pi on the top, pi on the bottom, cancel. 4 and 180. 4 goes into both. 4 goes into there once. 4 goes into there. Oh, 45 times. 180 divided by 4, 45. Okay, so we have 5 times 45. 5 times 45, and you get 225. 225 degrees. You have to have that symbol there. If you just left it at 225, that's implied, it's inferred that it would be in radians. And you want to make sure that it's in degrees, so you have to make sure that degree symbol is there. Here we go. How do you know that's in radians or degrees? It doesn't say radians, it doesn't say degrees. If it was degrees, there'd be a degree symbol there. There is no degree symbol there, which means this has to be in radians. It'd be so much nicer if they actually just made it obvious, radi, or just rad. Be nice if they did. Unfortunately, they don't. So that's in radians. So we have to multiply it by 180 degrees divided by pi. Oh. So I can't cross cancel anything here. In my head, I'm doing something, but it's not exact. This is approximately 3.14, and that would make it 2, but that's, nope. Don't do that. Negative 6.28 times 180 divided by pi. I have a pi button. If you don't have a pi button, you're going to have to use 3.14158 blah blah. And you get, did I just press clear? Let's try it again. Negative 6.28 times 180 divided by pi. And we get negative 359.8. Well, I'll just go to the nearest tenth. Just go around up the nearest tenth. Degrees. Boom. Fin. So make sure it's in degrees. Next, a little bit. Use a calculator to evaluate the trig function. Sine of, is that in degrees or what? What is that? There's no degree symbol there, so it means this is in radians. It would really be nice if they just did something like this. Make it obvious. That would be so nice. And they don't. Okay. So when I start with the calculator, when it's new to me, this is what I always do. I always do this. Take the sine of 30, because I know the answer is 0.5. So I should get 0.5. Sine 30 degrees, I should get 0.5. And I do. Perfect, I do. I don't know if you can see that in there. There we go. 0.5. So right now, this is in degree mode. This only works when it's in degree mode. Okay, that's not in degrees, that's in radians. So I could change this from degrees, I could change this from radians to degrees and then take the sine of that. I could, I'm not. I'm just gonna make it easy for me. I don't know if you can see that right there, but it says DEG for degrees right there. There's a button right here, it says DRG. Degrees, radians, gradients. Degrees you use in geometry and algebra 1. Radians. This is radians mode. This is what we're going to start being to use. That's gradients. We're not there yet. We're not using that yet. I'm going to change that to radians. Oop, I want to go back. Radians. There we go. Now it says rad. It's in radians right now. So I just have to take sine, and then I just have to type in 4 pi divided by 3. 4 times pi divided by 3. That's 4 pi divided by 3, and I just got to press my equal button. It's in radians. I just got to press my equal button, and there's my answer. Equals negative 0.8660. Boom, that's it. Done. Fin. And again, it ran off to the nearest 4 places. 1, 2, 3, 4. There, 1, 2, 3, 4. Okay, next, secant of 10 pi over 11. Again, it's not in degrees, that's in radians. Secant is just the reciprocal of cosine, so that's the same thing as 1 over cosine of 10 pi divided by 11. So I'm going to take cosine of 10 pi over 11, and then I'm going to take the reciprocal. So cosine of 10 times pi divided by 11, and then press equals. And now I have to take the reciprocal, and my reciprocal button is right there. Doink. And we get negative 1.0422. Cosecant of negative 8. Cosecant is just the reciprocal of sine, so sine of negative 8. That's the same thing as this. So I'm going to take sine of 8, sorry, sine of negative 8, and then take the reciprocal. Sine of negative 8. I'm still in radians mode. Take my answer, and then take the reciprocal. And the answer is negative 1.01078. So it's going to be 8. Bing, 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 boom. Fin. Hasta la bye-byes.